Hello, everyone. Welcome once again to today's lesson. And in today's lesson, we are going to continue from where we left off, with the lesson on permutation and combinations. So this is going to be lesson 6. In lesson 5, we looked at what permutation, where there is restriction on some of your objects, and the restriction is that your objects must not be together. Your restricted objects must not be together. And we said, for that one, the number of ways will always be the total number of arrangement, which is the arrangement with no restriction, minus the arrangement with what your restricted object being together. However, in today's meeting, we are going to zoom in, on combinations. So it means indirectly we are done with permutations. When you are asked to find the number of ways of arranging letters, digits, human beings, people, what have you. Now we are going to look at what? Combinations. So as usual, we have the basic understanding, the basic definition of what combination in terms of even its formula. So quickly, let's go through that. So this one too, I am going to group it under 2. The first one is A, where you are asked to find the number of combinations, the number of combination with n distinct objects, choosing R objects at a time. So n objects, and you choose what R at a time. So you know this is just the basic definition. So the number of ways will always be n, you choose what? R. N, you choose R, which by definition is n factorial over n minus R factorial, then R factorial. But we know that the R, must be between 0 and what? And n. It cannot go beyond n, and it cannot be negative, just as your n cannot be negative. So illustrative example, please listen carefully. We know that for permutation questions, we have to see, some keywords, arranging. However, if you don't see these keywords, then go further and see the situation, whether we are talking about arrangement or we are talking about selection. But with what combination, usually the keywords will be selection. If you see it directly, if it is not directly, indirectly, you have to go further to know whether you are dealing with what selection, or not. All right, so now illustrative example, find the number of selections, so the keyword is there, of 5 balls chosen from 8 different balls. So we have 8, we are choosing 5. Is that clear?
Yes.
So as usual, solution, number of ways, we know we said it to be n combination R. Your n is what? Is 8. Obviously, your n cannot be what? 5, and your R being what? 8, because your R cannot exceed your n. So the n will be the total number of balls that you are selecting from, and that is 8. And your R is the balls that you are selecting, and that will be 5. So then you come and use the definition. So 8 factorial, which is your n over n minus what? R, 8 minus 5 factorial, then 5 factorial. If you simplify, which we are experts, with this one, you write this one to contain 5 factorial, because you know this is the bigger, of the numbers in the factorial. So it will be better you write it in that form. You have this, information already. So the 5 will cancel, and the 6 will also cancel. Because your concentration is on this 5, it will still have the 5 factorial. At the 3, you will change it to each corresponding number, and that's a 6. So this will cancel, this will cancel. So you end up getting 8 times 7, which will give us 56 ways. Point well made.
Yes, please.
So take notes. With combinations, all the questions that you'll be dealing with at your level, we only deal with distinct objects. So with combination, you won't get repeated objects or duplicate objects. So all the questions that you'll be dealing with, the objects, at your level must be distinct. Point well made.
Yes, sir.
Great. So now let's move on to our real work examples. So the first worked example, an exam consists of 6 questions. Any 4 may be selected for answering. So you can see that the keyword is there. Okay, so as I read, okay, I underline the keyword, at least it will give me an idea as to whether I'm dealing with permutation or combination. Okay, in how many ways can this be done? So we are looking for the number of ways. Okay, the number of ways. So at this point, as usual, so question number one, so solution to question number one, then giving. So you always need your end, very critical. So we've been given, okay, number of questions, is that not it? So number of questions. To be equal to 6. Somebody can also write, giving 6 questions is the same. Am I right? Okay, so you have 6 questions. And how many are you choosing? How many are you selecting?
4.
Okay, 4. So I can say that therefore, my number of ways remember will be equal to this one. It will go there, so I will continue. It will be n combination r, but my n is 6. Okay, I know my r will be what? Will be 4. All correct. Okay, so you get 6 factorial by definition over, okay, 6 minus 4 factorial, but that is not all, okay, times what? 4 factorial. So in effect, we are going to get what? 6 factorial over 6 minus 4 is 2, so 2 factorial, then times what? 4 factorial. But, okay, I can write 6 to contain the bigger number here, 4 factorial. Okay, so on that note, I know that if I'm expanding, my target is 4 factorial, so I'll write the actual value of this. Okay, so it will give me 6 times 5, then times 4 factorial, all over. Okay, this 2 wasn't of interest to me, so I'll write its value, which is what? 2 factorial is 2, then times 4 factorial, and this 4 factorial will cancel that. This will also go here, 3. So in effect, I'm going to get 3 times 5, which will give me 15 ways. All correct?
Yes.
Point well made.
Yes, sir.
Okay, so this is the first example. Any questions? So usually combination without restriction, okay, is usually very easy. Okay, especially because you wouldn't get duplicates. Okay, the permutation without the restriction usually, okay, it becomes a little technical when you have duplicates. That's all. And I said abnormal circle, there shouldn't be issue. If you have duplicate, it means there will be a denominator. As simple as that. Okay, so now we come to question number 2. Okay, a committee has a membership of 10 men. How many 3-man subcommittees are possible? So here in this question, okay, can you see your keyword or words, any of them? Directly, can you directly see your keywords?
Yes, please.
Okay, so what will be your keyword to determine whether you are dealing with permutation or combination? If your answer is yes. What did I mention? Okay.
Possible.
Possible is your Who was that? You made my afternoon.
Adoma.
Anyway, remember for combination, he said the keywords will be choosing when you see choose, when you see select, okay, or any synonym, okay, close to this. Okay, however, you should know that you don't see choose, you don't see select. But when we are forming a committee, you should know that you don't arrange committee, we form a committee by selecting members, true or false.
True.
Okay, so indirectly, you should know that you are dealing with selection, not arrangement. I guess my point is well made.
Yes, sir.
Okay, so now let's go for our main, which is our end. That is very critical. So giving, Okay, we are told how many members. So we have 10 men. So let me use maybe, okay, in figures, so 10 men. Okay, so I'm dealing with math. So anything that I see in words there, I can write it in figures. Okay, so this is what we have. Now I write therefore number of ways. If for nothing at all, I know, okay, this is how I proceed. Number of ways, that's what we are looking for. Okay, and this will be equal to, okay, we have 10 men and the committee at every point in time. How many members are you supposed to get? Read the question carefully.
3.
3. So you have 10 men at every point in time. You are supposed to choose what? Choose what? 3. Because we are dealing with a 3-man subcommittee. So it will be 10 combination 3. Point well made.
Yes, please.
Okay, so which in effect will be equal to, don't use your calculator straight away. So use the definition first, 10 factorial over, okay, 10 minus 3 factorial. Okay, then your times your 3 factorial. Okay, which in effect will give us 10 factorial over, okay, 10 minus 3, and that is 7 factorial, and times 3 factorial. But you know, okay, between 7 and 3, 7 is bigger, so I write 10 to contain the bigger one in the denominator. So expand 10 factorial to contain 7 factorial, and that will give you 10 times what? 9 times 8, then times 7 factorial. All over, okay, your 7 factorial was a target. Okay, time the 3 factorial was not. So you write its value there. So 6. So 7 factorial will cancel 7 factorial here. Okay, now you know how to deal with this one. Okay, 2 will go here, 3. Okay, and go here, or let me even use 3. 3 will go here because, okay, 3 will go here, 2. Okay, that's a bigger number, that is this. And go here, what? 2. Oh, sorry, 3, forgive me. 2 will go here, 4. Is that not it? So we are going to get 10 times 3 times 4. So 3 times 4 will give you 12 times 10. So that will give us 120 ways. All correct.
Yes, please.
Okay, so you have 120 ways of selecting 3, okay, man subcommittees from a 10, okay, I mean from 10 men. Safa.
Yes, sir.
Okay, so far you can see the combination is so easy. Okay, you need to know your N and your R, basically. That's all. So now let's move on to the third one. Okay, and the fourth. Okay, so this, I mean, question 3 is a little different, okay, from what we've done so far. If you look at question 1 and question 2, let's go back. Okay, you were dealing with questions. So with this one, just questions. So one category. With this one, you were dealing with men, one category. So 1 and 2, we're dealing with, okay, one group of what? Of, okay, let me say one quantity or one group of situation. Let me put it that way. One object or one set, if I want to put it that way. Okay, Prof. Aduma.
Mr. Akman, please can you move to the previous slide?
This is the previous.
No, like the first one.
This is the first one. Or you mean where
the
I started
introduction.
the introduction one?
Yes, please.
Hey, baby, what do you could do? No.
Thank you. I'm done.
Okay, you're welcome. So at this point, we are good to go. So let's move on. So you can see that unlike this one, the first to look at this, you can see that we said in how many ways, so again, we are looking for number of ways, can a committee, so anytime you know you are forming committees, now you know you'll be dealing with what? Combination, not permutation. Of 5 women and 4 men, be selected from some 11, okay, women and 8 men. So if you look at this, you are dealing with people, all right, maybe one category. But if you look at the question critically, you can see that the question has, okay, let me say, yes, broken down the people into 2 categories, men and women. Is that clear? So unlike the first one where we were dealing with only men and only questions, okay, here we are dealing with men and women. Please, okay, it's not different from what we've done. Only that anytime you see two categories or two or more categories, they will be connected with end. And whenever you see end, okay, you will be dealing with multiplication. That's all. As simple as that. So by that, this is what I mean. Okay, so we are going to extract what we will need from the question. So question number 3. Okay, given, okay, so indirectly number of men. So let me put it this way: 8 men, sorry, 5 women. Let me, 5 women. Okay. Then what else do we have? And let me put it this way. Okay, 4 men. Okay, will our total number of women be 5 and number of men be 4? I want to see if indeed you are following.
Please come again.
The question is, okay, what I have here, you can see that I wrote giving 5 women and 4 men. And I'm saying that the information that I have here, is it precise?
Yes, please.
It is.
No.
Okay.
So you can see that it didn't prove further. Okay, so it is not. Okay, your number of women is what you need to write, the entire number of women and the entire number of men. That's what you have to write before you go for number of men to be selected, number of women to be selected, and that will be your R. So let's go and do the needful. So it's good, okay, you are following. So this is how best you can present your solution. Later, if you move on, I will refine the presentation as usual. So now I'll write number, giving number of women. So let me deal with what? A number of women. Okay, and the total number of women, what do we have?
11.
11. Okay, comma, number of what? Men. So I will always need my total. So I'll write my total first. What I will select from? Sorry, men. And the number of men, what do we have?
8.
8. Okay, but that's not all. We need the number of women to be selected and the number of men to be selected. So number of women to be selected. And you can see that I'm writing a lot, obviously, because there's the first example, okay, of this kind, to be selected. So the number of women to be selected is what? 5. Is that not it? And
yes,
the
please.
number of men to be selected?
4.
Okay, men to be selected. And as I said, as you mature, you would write all this. Okay, and that will be equal to what? 4. All correct. Okay, so now you are going to get therefore, if for nothing at all, number of ways. You know this is how you proceed. Number of ways. Okay, and this is what we are going to do. I'm coming down because maybe likely I will need a rough work here. So I will come down and write the equal to close to the margin. Now, okay, you can see that here you have 2 categories. And if my committee is supposed to, in actual fact, my committee is a 9-membership committee. Do you agree? Do you agree? The members of the committee should be 9. Only that the 9, 5 of them must be women and 4 must be men anytime I select. Is that clear?
Yes.
Yes,
Okay,
please.
so this is all that you need to know. Obviously, when you are going to choose women, you have to choose women from women. Is that not it?
Yes, please.
Yes,
And
please.
you choose men from what? From men. So the first one will be, I am going to choose 5 women out of a total of 11 women. So that will give me 11, okay, combination what? 5. And so end is multiplication. And I will go and choose 4 men out of a total of what? 8. So that will give me 8. Okay, I choose what? 4. Should I come again on my point is well made? Point well made, or I should come again?
Well made.
Well made. Okay, great. Okay, so at this point, okay, you are in a comfortable lead. Okay, so what you need to do is, I will tell you when you can use your calculator straight away. So now we are going to more or less work on our simplification skills. So you use the definition. So the definition of this one is 11 factorial over what? 11 minus 5 factorial, okay, times 5 factorial. Okay, that's it for the first part. Then times, this will give you 8 factorial over 8 minus 4 factorial. Okay, then times what? 4 factorial. All correct?
Yes, please.
Okay, which in effect will give us 11 factorial over, this will give us 11 minus 5 will give us 6 factorial, then times 5 factorial. Then times, the whole of that times 8 factorial over 8 minus 4 is 4 factorial, then times 4 factorial. So I know at this point you are in a good position, a pole position to, okay, deal with what you have there. So that gives us, you write 11 to contain 6. So 11 times 10 times what? Okay, 9 times 8 times, okay, 7, then times 6 factorial, all over 6 factorial. Okay, then times your 5, okay, factorial, but 5 factorial if you like, and you want to write it out as 5 times this time so that you can easily cancel, it is allowed. Otherwise, you use your calculator.
Factorial, you wrote 6.
Oh, it says
At the
factorial, sorry.
numerator.
At the numerator, forgive me. It wasn't intentional. So this will cancel. At the point that I was going to cancel, I would have realized that anyway. Okay, so 5 factorial will give us
120.
okay, so this would be 120. Okay, you can write it. But going forward, I will tell you that as you get to a point, you can use a calculator to find each of the numbers factorial, then work with it, the values. Okay, but I want us to continue doing this so that we will perfect our simplification skills. So that in a situation where you are not supposed to use your calculator, you won't be found wanting. Okay, so what was I doing? Okay, supposed to be times 7, forgive me, times 6, times, okay, 5, then times 4 factorial. Okay, all over 4 factorial. Okay, then times 4 factorial is what? 24. Okay, so this will cancel that. Okay, and I know how to simplify. So I'm going to rely on you. Okay, so unfortunately, the space that I have there, okay, cannot take what but I will squeeze it here. Okay, so we are going to get here, do the whole of this one for me. Going forward, I'll tell you what to do in this situation. Okay. How to bring in your calculator.
4, 6, 2.
For this side.
Yes, please.
4.
6, 2.
Okay, then times. Don't forget over 24. Times what?
70.
70. Okay, so you know your final answer will be equal to. If I go here, I will interfere with this. So it won't, when I write, it will not. So that's why I push it to the side. So whatever that you get there, you write ways. All correct.
Yeah.
Okay, so I'm waiting for your answer.
340.
3, 2.
340.
Okay, so ways as simple as that. Safa.
Yes.
Okay, all right. So now at this point, this is what we are going to do for that of the question 4, if you don't have any questions to ask. So question 4, how many ways can a committee consisting of boys, okay, 3 boys and 2 girls be chosen from 7 boys and 7 girls? Okay, so in this case, okay, this is what we are going to do. Okay, if you like. All right. So I am going to do this as my rough work. I will use J, okay, for girls, and the number of J, okay, will be equal to, okay, the number of B. So my rough work, don't forget, number of B. So number of boys, what do I have? 7. Number of girls, what do I have? I have 5. Is that clear? Okay, with this one, the R that I have there will be what? I'm selecting 3 of the boys. With this one, my R will be equal to what? I'm selecting what? 2. Is that clear?
Yes,
please.
Okay, so now the information that I have here, I'm noting that already. That's what I have extracted here. So what I'm going to do is I'm going to straight away draw my conclusion without extracting. Or I said, even if you want to extract, always extract, okay, your N. So maybe you can write, okay, given number of boys, number of girls. Is that clear? So let me go by that route, okay, or that route, and let's see. So that will be consistent, always giving, then therefore, if possible. So giving, okay, number of boys. Okay, what do we have? 7. Okay, and okay, number of girls. Okay, and that is equal to what? Is equal to 5. So I write therefore, okay, number of ways. Okay, will be equal to. Now I will select boys from boys and girls from girls. So I'm going to get, we said 3 boys out of a total of 7. So it will be 7 combination 3. Then and, okay, then how many? 5 girls, we are going to select 2 from them. So you get 5 combination what? 2. And you can use this information as well. So this will be equal to, now you write 7 factorial over 7 minus 3 factorial. Okay, then times what? 3 factorial. But that's not all. Times, okay, 5 factorial over 5 minus what? Okay, 2 factorial. Okay, then times 2 factorial. Okay, at this point, this is what you do. Okay, come and simplify your denominator, this one. Then after that, you can use your calculator, but I will tell you how to use your calculator. So 4 factorial, then times 3 factorial. Then times, okay, you are going to get 5 factorial over 5 minus 2, which is 3 factorial, then times 2 factorial. So at this point, this is how you use your calculator. Don't use your calculator to do the whole of this. Don't use your calculator to do the whole of this. As for everything, you know, obviously out. So now this is what you do. Use your calculator to find 7 factorial. So each of the numbers there factorial, use your calculator to find them. So don't go and expand anything. Okay, the expansion becomes necessary, especially when you have only one, okay, factor, okay, with the denominator. So as you mature, when you simplify, you can use your calculator. So I'm waiting for you. As for 4 factorial and 3 factorial, we know. So this will give us what? 24
5,
times what? 6. Then this will give you 5,
0, 4,
0, 4, 0. That's our usual 7 factorial. Then times, okay, 5 factorial, we know is what? 120. Am I right?
Yes, please.
Okay, over 3 factorial, which we know is 6, then times 2. Okay, so at this point, you are in a comfortable lead. I hope you should know what to do here. Okay, so you are going to get, if you like, you can reduce, but once you have the values here, use your calculator to do this straight away. Use your calculator. As ideally, we add, this is elective maths. We'll tell you to do this and this if it is called maths. So we are waiting. Okay.
50. No, 35.
This side is 35.
Yeah.
Then times
10.
10. Okay, which will give us 350 ways. All correct.
Yes, please.
Okay, very good. So this will be it, okay, for our first 4 questions. So let's move on and see whether we have, okay, so this will be for you. At the appropriate time, you do it as a classwork. Okay, but before that, I think I have to go back for those who want to capture. Before that, any questions? Any questions, my professors?
No, please.
Okay, so you are fine. Okay, we thank God. All right, so far, so good. Okay, so now the real deal. Okay, the real deal. But before we come to the real deal, I think let me grab this opportunity before we go for a water break. Okay, can't we do this one within maybe the next 10 minutes? We can, is that not it?
Yes.
Okay, so
No.
maybe immediately we'll come, I'll give you water break, then we'll come and look at the conditional, okay, combination. So this is going to be your classwork. I will capture it and put it on the platform right away. Okay, for those of you. So this is your classwork. Okay, I will leave it here anyway, but pause. Okay. Okay, so welcome back from the water break. Okay, now we are going to look at the second part of what combination, which is conditional combination. So just as the name suggests, here we'll be looking at combination, which is selection. Okay, where your selection is based on a condition. Okay, so in this case, we say that restriction imposed on some of the object to be selected. So this is a combination where conditions or restrictions are imposed on some of the objects to be selected. Okay, as simple as that. So with this, you know, we did that of the permutation. Restriction imposed on some of the objects to be selected and arranged. Okay, but here, some of the objects to be selected, we are not arranging. Okay, so still, you know. All right, so let's look at the following, okay, worked example. And at this point, I would want you to fasten your seatbelt. Okay, please. All right. Okay, so that's not to scare you. Okay, it's only to tell you that, okay, I think I should have added fasten your seatbelt and put on your thinking caps. Okay, so we are going to probe a little. It's a little technical. So you need to think a little before you can reason with me. Okay, you will appreciate whatever that I'm going to say. But as smart as you are, I am sure I'm not going to struggle to explain for you to understand. All right. Okay, so the first question, first word example. Out of 6 mathematics, it's supposed to be mathematicians. Okay, out of 6 mathematicians, okay, let me, once I can do the change and equally do that, so don't worry. Okay, out of 6 mathematicians, not mathematics. Okay, so I think, okay, that's okay. I don't know whether I wrote mathematics somewhere again. Okay, so that's fine. Okay, so this is it. Out of 6 mathematicians and 8 physicians, a committee of 4 mathematicians and 5, I think because I tabbed, it has changed the orientation. I didn't check the orientation of what I have there. So let me do that also quickly. Forgive me. Okay, because I typed so let me extend it to be, okay, so it's now back to normal. Thanks for your understanding. All right, so out of 6 mathematicians and 8 physicians, a committee of 4 mathematicians and 5 physicians is to be formed. In how many ways can this be done if A, any mathematician and any physician can be selected? So A, obviously, is trying to tell us that there is no restriction. Do you agree? Hello, do you agree? You agree. Okay, so now, remember I said the solution, you are more interested in the number, okay, that you are going to select from. So here again, we are dealing with 2 categories. Okay, so given, okay, I'm talking about number of what? Of mathematicians. And how many do we have? What's the total? 6. Okay, and okay, number of what? Physicians. And what's the number? 8, am I right? Okay, so there again, if you want to do your rough work, okay, so your number of M for mathematicians, okay, that is what? 6. Okay, and how many are you selecting out of your R will be equal, so let me use R sub M, okay, will be equal to, in this case, it's supposed to be made up of 4 mathematicians, okay, then number of P, physicians, and I'm looking at how many? 8. Okay, so R sub what P will be give me, I'm looking for how many? 5. So at every point in time, the committee, I need to have what? 4, okay, mathematicians and 5 what? Physicians. So it's a 9 membership what? Committee, sort of. Okay, so now let's go and look at the A. A, there is no restriction, so I'll write there for number of ways. Okay, will be equal to, I will select mathematicians from mathematicians and physicians from physicians. So mathematicians, I have, okay, 6 mathematicians and I'm supposed to select how many? 4, so it will be combination 4. All correct?
Yes.
And okay, my physicians, I have how many? 8. And I need to select 5. So it will be 8 combination what? 5. So at this point, I know you know how to proceed. So this will be equal to, use the definition. Don't use your calculator to find the values here. We want to see whether you appreciate that concept. So 6 factorial over, okay, 6 minus 4, okay, factorial, then times, oops. Okay, I think I've gone into let me see, I will manage. Okay, 4 factorial. Okay, so then times, again, 8 factorial over 8 minus 5, okay, factorial. Then what? 5 factorial. All correct.
Yes.
Okay, so if I move on to my next, we are going to get what I have there to be equal to, I write close to the margin. Come and simplify the denominator. So I'll keep my 6 factorial over my denominator. 6 minus 4 is 2 factorial. Then times what? 4 factorial. Okay, then the whole of that times, okay, 8 factorial over, okay, 8 minus 5 is what? 3. 3 factorial, then times what? 5 factorial. So at this point, you use your calculator. I'm waiting for you to do the individual. This is 2 times 4 factorial, which is 24. Okay, then times, this will give us what? 3, which is what? 6. Then I'm doing this one. This is 120. Am I right?
Yes.
Okay, then 6 factorial,
720.
720. Okay, 8 factorial, 5074. Am I right? Was that
40320.
40320? 7 factorial, that is 5040. 40320. Okay.
Yes.
All right, so this is what we have. So at this point, your calculator for this value. And so I'm waiting.
15.
15 here, then times
56.
okay, 56. Okay, which will give us
840.
840 ways. So in actual fact, the first one, the condition is that there is no condition. Okay, the condition is that there is no condition. The first one, it is not, in actual fact, it is not conditional, okay, combination. But once we see if, okay, and we see this indirectly with the if, with it, there is a condition, only that the condition invariably is trying to tell us that there is no condition, no restriction. Any of them goes. Now we are going to deal with the real deal. Okay, which will be where you have what? Conditions. So let's look at the B. Okay, so this is what I'm going to do at this point. Okay, this is how best I think I can explain to your understanding. Okay, however, if you still don't get it, please let me know. Okay, so now this is what I'm going to do. I am going to do this. Okay, maybe if in normal classroom setting, this is what I do. I will call 8 students, group them to be mathematicians, sorry, physicians, then 6 students, group them. Okay, then to be what? Mathematicians. Then after that, I start dealing with conditions. Okay, but now I don't have, okay, students available. So what I will do is I'm going to improvise. So I have, okay, my mathematicians. Okay, I'm going to use strokes to represent them. How many of them? 1, 2, 3, 4, 5, 6. Okay, am I right? And my physicians, how many do I I have 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. Remember, I always use strokes to represent people. Is that clear?
Yes, please.
Okay, so at this point, this is what we are going to do. So therefore, number of ways. Okay. If for nothing at all, that's what you know you write. And I'm bringing this the equal to down. Okay, so please listen. We said one particular mathematician must be selected. One particular mathematician must be selected. So assuming this is the particular mathematician who is selected. Okay, so whatever reason, one particular, okay, the selection is automatic. Is that clear? Whether you like it or not, that mathematicians must be part of what? Of the committee. I hope you are with me.
Yes.
Okay, so the condition, you can see that here the condition is placed on which category? Mathematician or physician? Mathematician. So you can see that the physicians, no restriction. Okay, and in combination, okay, and permutation, what we call combinatorics. Okay, whenever you are dealing with conditional, it will always reduce your n. If you realize, you can see that the conditional will always reduce our n. Have you realized that? It will reduce your original n.
Yes.
Yes, okay. So in this case, this is what we are going to do. So one person automatic. So it means that for mathematicians, okay, you've selected one, but how many mathematicians are supposed to be in the committee? How many mathematicians must be part of the committee? 4. So if one is selected, how many more do you need to go and select?
3.
3, but it will be 3 from the rest. Okay, the one that you've not circled. This one is not available for selection, remember. You get it? Because it's already selected. So if I'm going to select the 3, I will select the 3 from the remaining 5. Do you agree?
Yes.
So that will give me 5 combination 3. All correct. That is for the mathematician. But my, okay, Prof. Herbert, let me finish. Okay, I will okay, call you. If I forget, remind me. Okay, so my mathematician's restriction is on 8. So my n has reduced. Okay, then times, okay, always, you know, the membership should be mathematicians and physicians. But physicians, you don't have any restriction, okay, any conditions imposed on any of them. So it means for the physicians, you still have your 5 physicians to select from what? From the 8 physicians. So that will still give us 8 combination 5. All correct. Should I come again? Or Prof. Herbert, now you have the opportunity to ask your question. Yeah, I'll go over, don't worry. Okay, I'll go over. You get it. I've told you it's a little technical. But once you get it, okay, you will be eager to put up your hand, even if I don't ask you to answer. Okay, Prof. Herbert.
Sir, please, I'd like to ask, how did you get the 5 committee and the 5 combination 3?
Okay, I explained, but maybe you didn't get it. Okay, we can see, we said that with the mathematicians. Okay, so I'm going over. Here, the condition is placed on mathematicians. Physicians know, okay, condition. So if for nothing at all, I know that I am going to always, it will be something types. You get it? Always your result, because you are dealing with 2 categories, it will be something like this. Okay, CC. You need to find the N here and the R here, N here, R here. Is that clear?
Yes, sir.
Okay, as for this one, if I'm taking this to be my physicians, as for physicians, no restriction. So I still have my 8 combination 5. Is that clear? Because there is no restriction, so it's still intact from this point of view. I still have 8 physicians to choose what 5 from. Is that clear?
Yes.
Okay, now you come to the restriction is on the mathematician. But the mathematician, what is the condition? What is the restriction? The condition or the restriction is that the one of them, okay, must be part of what? Of the committee. So it means he said one particular mathematician must be selected. So assuming this is the one mathematician who is selected. Okay, so it means already for the mathematicians, I need to have 4 of them, but 1 is gone. I've selected 1 already. Am I right?
Yes, sir.
Okay, so if I've selected 1, how many more do I need to go and select? The membership in terms of mathematicians should be 4. So if 1 is gone, I've selected 1. I need how many more?
So you need 3 more.
3 more. But the 3, remember what I have circled here is already selected. So if I'm going to select the 3, I will select the 3 from the remaining 5. You get it?
Yes, sir.
You get the point now. So that is what will give you 5 combination 3. Alpha.
Yes.
It's clear now.
Yes, sir.
Okay, Prof. Adoma.
Mr. Hackman, please. So it means that when you circle out that one particular person, that doesn't play a role in the formula in any way.
Okay, in way it plays a role. That's why I've told you immediately is conditional. Okay, something will happen in your formula, and especially your n will be affected. Okay, it's either your n will be affected. Let me say, at least your n will be affected. In certain situations, both your n and your r will be affected. And you saw that in this case, our n was affected. Okay, that also affects our r. It affected our r. Can you see that?
Yes, please.
Because we said this person was selected. Okay, so
Yes.
here, always as for your n, it will reduce. But whether your r will reduce or not will depend on the condition. And
Yes.
very soon you will know. Okay, now you know that this one, because we are told that the person must be selected, it means that selection is already gone. So your r, if you are going to select again, your original r, which is 4, is short by 1. So if you are going to select, you cannot go and select 4. Other than that, if you select 4 and you come and add it to the one that is there, you have how many mathematicians in the committee? You have 5, but the condition is that you are supposed to have only 4. You get it?
Yes, please.
So that will give you, and I think from here you should be able to proceed in terms of your algebra. So I won't do it up to the end. I will only explain. So this will give you 5, okay, factorial. So just do the definition after that. I will ask you to continue, okay, and do it later. So times what? Your 3 factorial. You extend this to cover. Then times your 8 factorial over 8 minus 5, okay, factorial. Then times what? 3 factorial. Oh, sorry, times 5 factorial, forgive me. So now you know this will give us 5 factorial over 5 minus 3 is 2 factorial times 3 factorial. Then times 8 factorial over 8 minus 5 will give you 3 factorial and times 5 factorial. In any case, this one, you've done it here. Okay, is this that will change? Is that clear? So you use a calculator to find this, then you simplify. All correct. Or we should do it up to the end.
Yes, please.
Okay, so that would be, so you continue. So this would be equal to, as for the algebra here, sorry, 5 factorial, not 5. So 5 factorial, we know will give us our usual 120. Was it yes, 120, right?
Yes, please.
Okay, then over 2 factorial, which is 2, times 3 factorial, which is 6. Then the whole of that times, okay, we know that 8 factorial will give us, so this one will basically be the same as this. So 4, 0, okay, 3, 2, 0 over, okay, 6 times what? Because 3 factorial is 6, then 5 factorial is 120. Okay, so this will give us, I know this will give me 56, like you said. I'm inferring from there.
10.
Okay, so I'm waiting for this.
10.
10. Okay, so this gives you 10. So in effect, you are going to get 560 ways. Safa. Okay, so going forward, I'm going to plead. Immediately we are able to, this is the notes. Immediately we are able to write this. Okay, I believe you should be able to use the definition to write it, break it down this way, to end here and later use your calculator. Is that not it? So I won't do it up to the end so that we can cover more. Is that clear?
Yes.
Okay. So at this point, we are going to move on to the next one. We are not done. Okay, any questions before we move on to the C and the D? We have a whole lot of the conditions. I'll make sure that we take care of all the basic conditions. Okay, today. Then later, if time allows, which I know time will, okay, we'll look at there. So we are going to look at C. Okay, C again. Okay, my rough work. Okay, so what do I have? Mathematicians, I have 1, so M. Okay, I have 6 of them. So 1, 2, 3, 4, 5, 6. And the physicians, I have how many? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I come therefore number of ways. I'll come and explain how you continue. So if for nothing at all, at least you have to know that you write number of ways will be equal to. So now you check. So let's look at the condition for C. One particular physician must be selected. So it means here you have restriction on mathematicians.
No, please.
So your mathematicians, you still have what? Okay, 6 combination 4. Select 4 from what? 6. So that will give us 6 combination 4. Is that clear?
Yes, please.
Then times your restriction is on the second part, which is the physicians. Okay, physicians, what is the condition? One particular physician must be selected. So assuming this is the particular physicians who must be selected, this one, selected. Okay, so once that person is selected, physicians, how many of them must be part of the committee?
5.
5, but you can see that 1 is gone. So you need how many more?
4.
4, you will select it from the remaining, is that not it?
Yes.
Okay, so that remaining will give us
7.
7. So it will be 7, okay, combination 4. All correct?
Yes.
Okay, so at this point, I believe you can use the definition to write, okay, and continue. Afa. Okay, this is the first. Once some of you are more or less communicating along, singing along, let me put it that way, then it means you are following, and I'm happy. Those of you who are yet to come on board, don't worry. Okay, everyone will be on board before we end the class. Okay, so at that point, I've told you I'm not going to continue. This is the note. Once we are able to get it, if you cannot proceed, okay, then I don't know. Okay, so take note. I know you can proceed. So let's look at the D. Okay, so the D again. So this time around, this is what I'm going to do. I'm still going to use this. Other than that, you will use, okay, the strokes. I will indicate the strokes again, but it doesn't really matter. This is the first set of examples. So let me do that, okay, again, though I think it will waste my time, but it's for a good cause. So 1, 2, 3, 4, 5, 6 mathematicians, physicians, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now therefore, number of ways. Okay, will be equal to. So here the condition is on which, okay, category? Which category, mathematicians or physicians? The D.
Mathematicians.
Mathematicians, very good. So in this case, okay, it means our physicians will be intact. So mathematician is what we are writing first. Or it doesn't really matter. It will always be multiplication, which is commutative. So you can write that one, physicians followed by, but I want to keep the original position. So physicians, we are going to get, we still have what? 8 physicians to select 5 from. So to get 8 combination 5, is that not it?
Yes, please.
Then we come to the mathematician. Mathematician, the condition is that 2 particular mathematicians must be selected. So assuming this time around, it is these 2, okay, who are selected. So it means automatically 2 selection gone out of the 4. So how many mathematicians more that I need to go and add or select?
2.
2, but the 2, I have to select it from the remaining 4. Is that not it?
Yes, please.
Okay,
Yes,
so that will
please.
give us 4 combination 2. Afa.
Yes, please.
Okay, so at this point again, I presume you can continue. Use the definition for factorial, 4 minus 2 factorial times 2 factorial. Then this one, you can continue. All correct.
Yes.
Okay, so we are done. The E will be yours. Okay, so let me see if someone can try the E. Okay, so anyone to try the E to convince me that indeed you are fine. And you can see that all along, I've not been canceling my rough work, but you are supposed to cancel it. Is that clear? So let me do the needful as well. As for this one, you all know. Okay, so who mentions, and somebody just talked. Who was that? Adama, were you the one?
No, please.
Okay, so you always be my prime suspect before.
Yes, please.
Okay, so who was that? Who mentioned Mamiya's name? You can see that head. Who was that? Okay, so who wants to try? Let's go. The E. 2 particular physicians must be selected. Who wants to try? Oh, my professors, this afternoon, I don't know what is happening. Oh, you think you are still, your understanding is not up there. So we should do that together. Okay, Prof. Ama, yeah, boy, let's go.
So E,
E.
and then we do our rough work.
So assuming the rough work is here.
So therefore, number of ways
Okay, therefore, number of ways
will be equal to
So let's do the
6
rough work here,
combination.
so that you can 1, 2, 3, 4, 5, 6. Okay, then physicians. Okay, 1, 2, 3, 4, 5, 6, 7, 8.
So this time around is 2 particular physicians. So we circle 2.
Okay, 2.
Physicians.
Okay, here, is that not it?
Yes,
Okay,
please.
so this one selected. Okay, so now let's go.
So 6 combination 4.
Okay, so 6 combination 4.
Mathematicians.
No restrictions, so
Yes,
perfect.
please.
Please, do you agree?
Yes, please.
10
Yes.
times, okay.
Then times 6 combination 3.
6 combination 3. How did you get your 6 combination 3?
Because 2 particular physicians must be selected. So the number of physicians now will decrease. So you have to subtract 2 from it.
Very good. So you subtract 2 from N and 2 from also R. Is that not it?
Yes, please.
Very good. So that will give us 6, okay, combination 3. As simple as that. So you select the remaining 3 from the remaining physicians. So it will be 3. The remaining physicians will be 1, 2, 3, 4, 5, 6. So it will be 6 combination 3. Then from here, I guess you can proceed. Well done. Okay. All right. So please, are we all fine? So now we know if the condition is that, okay, a particular member or some membership must be, okay, part of the committee, we know how to deal with it. In this situation, we realize that both the N, okay, and the R, okay, will be affected. So now let's go and look at the other situation where the question comes in the negative sense. The condition is in the negative sense. Okay, quickly, so let's look at the next set of questions. Okay, all right. So it's the same thing. I didn't want to change, only that I've changed the same condition, I should say, but I've changed, okay, the questions here. So the same preamble, okay, the questions that, okay, we are going to look at it from a different angle. Okay, so 2, the same 2, but we are, oh, sorry, that was 1. Okay, so now 2A is the same, okay, only that I didn't want to. So again, my number, so you extract, giving your number of, so that will be your general information before you come to A. Is that clear?
Yes.
Okay, so let me equally do the needful. Okay, so, and I want to be smart too and present it in another way. So I want to write, let's, okay, P be equal to physicians. Okay, more or less the set of physicians. Okay, then M. Okay, I could have started with M as well. Okay, mathematicians. I want to do something which indirectly is trying to tell you that you can also do some mathematicians. Okay, so not mathematics. Okay, so in this case, I can say this implies that number of P, okay, is equal to what's the number of P? 8. Okay, and number of M, okay, is equal to what? Is equal to 6. You get it? It's the same thing. Instead of writing number of way in the West, number of, I can do this. Is that clear?
Yes.
Okay, so now we are good to go. Okay, so I'm interested in what we are going to do. I should say more interested in what we are going to do here. So therefore, number of ways, we go and do our rough work. Number of ways. Okay, in actual fact, you should have done your rough work before this, but we know that we always start with number of ways, so we can do that. So M, okay, 6, 1, 2, 3, 4, 5, 6. P, 8, 1, 2, 3, 4, 5, 6, 7, 8. All correct?
Yes, please.
Okay, so now let's see. The condition is that one particular mathematician cannot, so negative. Is that clear?
Yes.
Okay, so just like, let's say you are going for intercore or Suzo, okay, and for whatever reason, maybe your class is supposed to go, let me take Adoma's class, but maybe for whatever reason, Adoma cannot go. Okay, for whatever reason. Okay, and you should know the obvious reason that, okay, she can't go. Okay,
Mr. Agma, please switch it.
Okay, so Adoma cannot be part. So once Adoma cannot be part, so it means Adoma is not available for selection. Am I right?
Yes, please.
So this is a natural situation. Sometimes when you are going for intercore, a certain class, okay, will be exempted, or certain individuals will be exempted. Okay, or certain individuals, it's automatic. That's why when you go to school, especially in Wesley Girls, all of you want to join, okay, Red Cross. Okay, because you know, as for Red Cross, you should always be part. Okay, so it's a natural situation that you can relate. So in this case, I said, okay, we said the restriction is on mathematicians, is that not it? So not on what? On the physicians. So the physicians, your selection will be intact, and that will still be 5 out of what? Out of 8. Is that clear? Point well made.
Yes.
And please take note. Okay, take note. Okay, don't go and write 5, okay, combination 8. You know, your R cannot go beyond your, it cannot be greater than that. So now we come to where there is a restriction. So I am coming to that. No restriction here, restriction. So if one particular cannot be, then assuming this one, okay, so, oops, what happened? Okay, all right. So this is what we have. This one cannot be selected. Am I right?
Yes.
Okay. So if that cannot be selected, okay, your mathematicians, have you selected any of them? No, you still have your 4 mathematicians to select. Is that not it?
Yes.
Only that the number, okay, of mathematicians that you are going to select from, that will be short of 1, because Adoma cannot be part. You get it?
Yes.
Okay, so you still have, okay, your 4 to select. However, out of a total of what? The remaining what? 5. Am I right?
Yes, please.
Yes,
Okay, so
please.
that will give you 5 combination what? 4. So you can see that when we are dealing with cannot, it is only your N that is affected. Is your R affected?
No.
No. So anytime you are dealing with a negative, cannot, it is your R, okay, which will not be affected. However, your N, I've told you, always your N will be affected. But if your R will be affected or not will depend on the condition. If it's negative, your R will not be affected. If it is positive, your R will be affected. All correct?
Yes, please.
Yes,
Okay,
please.
so I guess from here we can all continue. Am I clear?
Yes, please.
Okay, so we are going to move on to B. Okay, so B. Okay, again, this is your rough way, strike it out. Okay, so B, what do we have? We are going to do our rough way. What's the condition? Okay, one particular physician cannot be selected. Okay, so I'm going to do my P, okay, my M. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, so now what do I have there for number of ways? Will be equal to. Okay, with this one, let's see. The restriction is on physicians, is that not it, but not mathematicians. So mathematicians, it will be intact. So I will still have, okay, 4 to select from 6. So that will give us 6 combination 4. Is that clear? Then times, I come to the physician, that's where the restriction is. So with this one, you said, yes, please.
Please, the physicians, they are 8.
They are what? 8.
8.
And I did what? 1, 2, 3, 4, 5, 6, 7. Oh, okay. I didn't count well. 8. Okay, thank you. All right, so now we have what? For the physicians, we said one particular cannot. So assuming this is the one particular who cannot. So this is not available for selection. And we should also know that, okay, you have not selected any of your physicians. So you have what? 5 physicians still to select. However, from the remaining what? 7 physicians. Is that clear?
Yes.
Okay, so that will give us 7 combination what? 5. Afa. Hello, is my point well made? Are we all fine?
Yes, sir.
Okay,
Yes.
great. Okay, so we are going to move on. So I think again, once again from here, okay, you should be able to continue and get your final answer. So let's look at what that of what the C. Okay, so this is happening to be a rough word. Don't forget to strike it out. Okay, C, what are we dealing with there for a number of ways? We'll go and do our rough work. Okay, so rough work M. Okay, 1, 2, 3, 4, 5, 6. P. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now let's go. This will be equal to, what's the condition? 2 particular mathematicians cannot be selected. So restriction on mathematicians, physicians intact. So I will still have my 5 to select from 8. So 8 combination 5 for the physicians. Is that clear?
Yes.
But the mathematician is where the issue will come. So I am going to work on the mathematician. The condition is that 2 particular, so these 2 cannot, okay, be selected. So they are out. Okay, however, once they are out, you still need to go and select. And you can see that you still have what? 4 mathematicians to select. Am I right?
Yes, please.
Okay, out of what? The remaining mathematician, and that will be 4. So that will give us 4 combination, what? 4. Is that clear?
Yes.
And with this one, I don't expect you. Take note, this is a special situation. Remember, I told you that you should know at your level, you should know N combination 0, N combination 1, and N combination N. Is that not it? So we said any number combination 0 is what? Is 1. Any number combination 1 is the number itself. Any number, okay, combination itself is equal to 1. So in this case, instead of coming to write, okay, 4 factorial over whatever, I know that this straight away will give me 1. Then I would rather come and use this one because this is a special situation. Okay, come and write this one as 8 factorial over because that's not special. 8 minus 5, okay, factorial, then times 5 what? Factorial. So far. All correct, my professors?
Yes, please.
Okay,
Yes,
so
sir.
on that note, let me see. Okay, help me with the D and the E. Okay, I want someone to help me with the D and the E. Or maybe the E. Sorry, the D. I will see if I can give the E to you as an assignment. Okay. Hello, my professors, are you there?
Yes,
Yes,
please.
please.
Who wants to try the D? The D is up for sale. In fact, if it's for sale, then it means you have to buy it. It's a freebie. It's up for the taking. Oh, my professors, don't do this to me. Oh. Okay, I think you want me to call, so I'm going to call. Okay, Prophet Rama. Prophet Rama, are you there? If your audio is not working, let me know. Otherwise, this morning too, I called you, you didn't respond. Okay, and you didn't tell me anything. Okay, Prophet Christine. Is this a question or you want to try?
Please, I want to try.
Okay, that's right. Let's go.
D. Therefore, number of ways.
Okay.
Then R of work, M
Okay. Okay, M.
is 6 strokes.
Mm-hmm.
And P is 8 strokes. And we'll circle 2 because 2 cannot be selected.
2 from where? M or P?
P.
Okay.
So the number of ways will be equal to, for M is 6 combination 4.
Okay, no restrictions. So 6 combination 4. Perfect.
Times. For the P is 6 combination 5.
6 combination 5. Okay, you are selecting the 5. Okay, from the remaining ones. Very good. So 6 combination what? 5. Okay, so at this point, you should be able to continue. So thank you very much, Prof. Christine. Okay, thank you very much. All right. So on that note, the E will be yours. Okay, you do it later. Let me see whether the time will allow us to do. Okay, so the other ones, possibly in our next meeting, I will take. So in our next meeting, we'll look at where the condition, you can see that the first one, okay, the question 1 and the question 2. Okay, question 1, we're dealing with condition which is positive, must be selected. Second one, question 2, condition which is what? Negative. However, for each of them, question 1 and 2, you realize that restriction was imposed on only one of the categories at any point in time. So in our next meeting, we'll look at a situation where restriction is imposed, okay, on more than what? One, okay, of the category. So you can see that one particular mathematician, so restriction on mathematicians, and one particular physician, restriction on physician as well. So we'll look at, okay, such situations and how to deal with that in our next what meeting. Is my point well made?
Yes, sir.
Okay, and I think, okay, your understanding is also better. So I will leave this one with you. That will be your assignment, but I will put it on the platform. It's going to be a long weekend, is that not it? Okay, so I will see if I can send, okay, maybe by our next meeting, which will be on Thursday, no, Tuesday. Okay, by Tuesday, I will see if I can send, okay, the second part of what? This conditional combination for you. Okay, if not, then we have to meet on Tuesday, then complete whatever that we are supposed to do or conclude. Okay, so at this point, thank you very much. Okay, it's been wonderful being with you this afternoon, as always. Okay, so God bless us all.